In this video we will solve a problem involving the arc length function. So the question says, suppose we start at this point on the given curve and we walk along the curve a distance of 3 units. What is the point that we end up at? So first we'll answer an easier question. We'll find out what is the value of t at the point where we end up at. And then to get our answer, we'll just plug that value of t in to this function r. But how do we get that value of t? Well, we need the arc length function. So let's compute it. First, before we can get the arc length function, we have to take the derivative. So we need to compute r prime. So the x component is just 2. The y component is 2 square root of t. And the z component is just t. So that's r prime. Now we need the norm of that. So the length of the r prime vector. That's the square root of 2 squared plus 2 squared of t squared, which is 4t, plus t squared. But if you'll notice, the quantity under the square root sign is itself a perfect square. 4 plus 4t plus t squared is the quantity 2 plus t squared. So this is just equal to 2 plus t. Now let's make an observation here before we move on. The point 5, 4, 7 is the point when t equals 0. Alright, if we plug 0 into the function r of t, we get exactly 5, 4, 7. So we need to know that. So we want the arc length function starting at t equals 0. So let's write that down. The arc length function s of t is the integral from 0 to t. Again, the 0 comes from this, the fact that our designated starting point is when t equals 0. We need to integrate this quantity here, the length of the derivative vector. But I'm going to use a different letter than t because we're already using t as the upper bound of the integral. So I'll use u. So 2 plus u du. So this comes out to be 2t plus 1/2 t squared. So that's our arc length function. This is saying that after time t, this is how far we've moved along the curve. This is the distance or the length that we've traveled. So finally, let's look back at the question. We want to move 3 units. We want to find out how long does it take us to do that. So again, s is the arc length function. The value of s represents how far we've moved. And we want to move 3 units. So we want to answer the question, when is this function equal to 3? So we just need to solve this. So s of t from above was 2t plus 1/2 t squared. When is that equal to 3? So this is just a quadratic equation. This isn't hard to solve. We can just use the quadratic formula. So if we move things around and multiply everything by 2, we get this equation. T squared plus 4t minus 6 equals 0. And if we just use the quadratic formula, you'll find that t is negative 2 plus or minus the square root of 10. But if you think about it, we don't want the minus. We only want the plus, because we're only going to consider positive values of t. Back up in the question, it said moving in the positive direction. So we don't want a negative value for t, so we only use the plus sign. And we're almost done now. So we've sort of answered the question. We've moved 3 units along the curve when t equals the square root of 10 minus 2. But the question wasn't what value of t, but what position. But the function r is the position function, so we just need to plug this value of t back into the function r. So our final answer is just r of this number, the square root of 10 minus 2. So just plug this number back in. And it's going to look kind of nasty. It's not going to be very simple, but whatever. Just substitute it everywhere. So the first component was 2t plus 5, so 2 times this plus 5. The second component was 4/3 t to the 3/2 plus 4. And finally 1/2 t squared plus 7. And that's it. Let's not try to simplify it. We'll just leave our answer like this. So this is the position that we end up at after traveling a distance of 3 units.